places like in Europe where they actually use copper as a cladding material. They like to use Corten steel, for instance, or use natural timber, and they like how the timber ages. But there are many clients here in Singapore where you get it at this color, and if it turns gray, the client complains, is not happy. So this becomes a very, very subjective subject matter as to how or whether we actually want for the timber to actually age through time. Okay. Then, of course, the other thing that we have to watch out is, and a lot of this will boil down to pre-planning, is how you basically run your services through the building. Because the basic principle is that the timber members are basically designed to accommodate the entire load that they're supposed to have. So unlike with RC, where your CNS engineer will occasionally allow you to punch a hole or a sleeve for which your services will run, in an MET building, punching holes is completely unacceptable and will compromise the structural integrity of the building. So thus, we have to basically use several different means of running services and coordinating. And I think this is part of the design criteria which you will have for the competition. Okay, some of the details. Okay. So the project by which we have used this is for the Rivervale Community Club in Sengkang. The project is currently under construction. Okay. The site is actually very, very close. It's actually at the back of Rivervale Plaza for those who are familiar with the area of Sengkang. This is the site there behind the multi-story car park. Okay. So we designed it in a way that you basically have a pedestrian entrance and a vehicular entrance that basically links up across a double volume space. And above it is basically, it's a donut building. We basically create an atrium by which all the different areas are clustered around each other. Okay. And then basically as you go up, you basically have the multi-purpose hall and all the different areas coming up directly above it. So when we take a look at how the system works, it's basically got glue laminated columns. The walls are using cross-laminated timbers. Okay, and the entire basement and the bottom portion of the first story uses concrete. And then we use a steel bond deck for the roofing for the protection. And the facade is entirely clad in aluminum to basically address many of the issues that we talked about earlier. Okay. So when we basically take a look at how the whole system is constructed, okay, one of the things that this basically allows is that when we talk about PPVC, one of the limits is basically you have the 3.4 meter dimension, which basically limits the span of your structure within the building. So this system, you can have bigger spans, but of course, bigger spans also mean bigger columns and huge, gigantic beams. Okay. Okay. And we've also tried to address some of the issues in terms of protection. We have basically a layer of aluminum protection at the external. Okay. And the detailing, the metal work is very, very difficult. We wanted to basically propose planter boxes. It's a very, very elaborate feat of gymnastics to try to just install a planter box on a MET building. Okay. So I think the conclusion about MET is that it is new. There are still many issues that are currently being worked out, particularly concerns of SEDF for issues of fire. But it is a technology that is worth considering, I think. And further down the line, there will, just like we have taken steps forward in evolving PVC, 2D construction to PVC to PPVC, and improving the PPVC system in itself. We expect, of course, down the line that we can have steps forward as well in MET construction. So I think all in all, when we take a look at DfMA, when we think about what the future is going to be like, I think it's probably going to be a hybrid of what we have with PPVC and MET, where in a way it's almost like a flat pack system that you basically bring on site, and hopefully with the use of more and more ecologically and environmentally sustainable materials. Okay, so there are many resources on the system, and so I think that's why I've named my talk as such. When we talk about the competition, we hope that we don't think of just the how, we think of the why, and how the building behaves in the general spirit of what the building can be like. And you have to think about it as a place that all of you will enjoy working in one day when you guys join the workforce. And that's it. Thank you. Yeah.
Thanks, Mark, for a very enlightening talk. We really enjoyed the slides. I think it's really useful.
Thank you.
So any questions for Mr. Ong? You can check with him on anything that he has shown, or even something that actually is bugging you. You can actually ask him, for some clarifications if you want. Please.
generally the shy one.
You mentioned about the size of the PPVC being,
Yeah.
there's a limit, right?
Yeah,
So
3.4, yes.
So the one, the NTU one, you're at 10 meters, so you need some kind of a...
No, so the 4-meter module, we broke it down in 2 plus, 2 plus to be joined together. To join it together, yes. Yeah. Yeah. Yes, yes. Sorry? I think a lot of that will be solved using BIM. Sorry? Yes, yes. Okay, the software that I think each individual firm uses will boil down to general consensus of the people within that firm, within that company, in terms of why you use that particular software. For us, for example, because we're more on the Archi side. I mean, I'm working on the Archi side. We have a structure department. So for us, for example, when we started to use BIM, we were using Revit, okay, and I think about 5 to 7 years ago, we turned our office. It's basically an architectural firm by day. It was a BIM school at night. So basically, our staff, including myself, we had to stay for 2 weeks, almost like 4 weeks. So it's like every day. Then you had to like spend 2-3 hours after work just to learn the software. And eventually, we found that it was very, very taxing on the hardware. It was very, very taxing on the hardware, and it was we found a lot of challenges using the software. So we have since shifted and to ArchiCAD. So ArchiCAD, at least in my opinion, and I'm expressing a personal opinion, and I know that I'm speaking to a room filled with Revit users. Okay, it's a little bit more intuitive. It's a little bit more similar to design by SketchUp, so it's a little bit more seamless. It doesn't necessitate a lot of upfront commitment to certain things that are easier to change further down the line, as well as things like practical things like the cost of the software, for instance, and such, and the general preference of the consultants that we normally work with, which software they generally prefer to use. Especially now, we know we are a minority. The industry predominantly uses Revit, so we know we are a minority. So what kind of coordination software they prefer to use when we do clash detection. So we try to adapt in that manner. Okay. Yeah. Okay. Yeah, sure. Joint, yes. Okay, each that is essentially an engineering problem. So the way our engineers designed it is that while the component is being transported, so basically you'll notice that in the slides that each component, actually what happens is that each column is split into two. So what happens is that each component, while it's being transported, functions as an independent structure. But structurally, when they are stitched together, they behave as a single structure. One of the downsides actually of using PPVC is structural redundancy, because your columns do not need to be that big, but they become that big because you want them to also be able to function independently. So in a way, you have to account. There is a safety factor that we account for, or at least the engineers that we work with, they account for in case the joining is not, the joining does not allow the column to behave seamlessly together. That they allow for a certain percentage of structural redundancy. So of course, the quality is down to the stitching method, and of course, each contractor. Right now, as we explore this new frontier, has a different system. They have whether they just simply grout it or they have special details, many of which are actually still patented in terms of the way they join members together. Yeah. That is also one of the issues right now that the PPVC is facing. For example, we showed you the condo projects. For example, the condominiums that we have launched using this system. For example, the sales and purchase agreement that a buyer of the unit must sign off to is that even things like if they want to mount a TV on the wall, they have to sign off that they will not penetrate with screws the walls deeper than a certain depth to not affect the structural integrity of the building. Because, and of course, one of the things that if you take a look at renovation sites, for example, if you go to Renopedia or Canvas, this kind of thing, the common thing that people love to do locally, I mean, Singaporeans love to do, I design a lot of public housing. A common thing a lot to do is like, well, let's say when a couple buys an apartment, for instance, they say they buy a 4-room flat, for instance. So it's a master bedroom and 2 common bedrooms. So the first common bedroom normally becomes the man cave, and the second bedroom normally becomes the wife's walk-in wardrobe. So then normally they have to knock the walls in between the 2 spaces. So this is a very, very common renovation thing. So what happens with PPVC is that because the beams are attached to the columns, you cannot so-called anyhow remove the columns, especially if the walls, if you use a shear wall system, which is some of the things that we're trying to overcome. Let's say for our HDB projects, you'll notice that the columns are slightly protruding out, so that if the homeowner wants to knock over a wall, you will still have a column protruding into your space, but at least the column, we're minimizing the extent of the column eating into your space. So we're trying to address the issues in that regard, or whether we can use the columns, for example, as an architectural feature. We're launching a project in Tengah where we're actually doing that. We took the column and we projected it out of the unit so that we use the column to support a the column becomes double purpose. It also serves as a sunbreaker. You make the space internally column free. So we try to think of architectural solutions in that way, but whether we can so-called remove a column, I think we are, at least in the industry, we have not yet reached a point where we have the know-how to do that. Yeah. Yeah. Okay. Yeah. So the ice is basically basically having a coordination. It's not very, very different from having a traditional coordination meeting, except that you're actually doing it while you are going through the BIM model. And of course, we go through each project or each company, each firm will have a protocol set of things to go through, to a checklist to make sure that we were able to basically iron through all of the different pieces together, the considerations of CNS, M&E, and so forth. Yeah, sure.
So is there a computational approach to rationalize, to optimize, and analyze different modules, how they combine together?
Computational approach, you mean?
Yes, which means we're using visual programming or we still manual. How do you approach the optimization?
I think right now, it's still manual based. I know what you're getting to, like, for example, applications for example, things like Grasshopper, for instance, right? So when I think about, let's say, applications to Grasshopper in the current set of projects that we work on, for example, we work in public housing. I like to use the term, it's a self-invented term when I think about how HDB blocks are designed. It's a term I use, it's a necklace system where you basically have a common corridor, and then you basically have prototype unit plans that are plugged into it like pendants in a necklace. That's why I call it the necklace system. So, for example, if you want the building to be L-shaped or to basically L with a diagonal, there are actually ways by which you can inject parameters using software like Grasshopper. For example, you can inject, for example, firefighting regulations, for example, smoke lock considerations, staircase ventilation requirements. You can input it into Grasshopper software, and it can automate. For example, I've seen people with the capability to automate possible layouts using, let's say, for example, I want 5 3-room flats and 10 4-room flats in one block, and then you try to use Grasshopper to automate it. You can do things like that. However, in a way, we are waiting for the next wave of the next generation of people who know how to run the software seamlessly, possibly amongst one of you one day, in order to be able to fully synthesize it into the way we do design. However, in terms of the way we do designs manually, everything is still very, very traditional in the sense that we still think about space, we think about what space relates to the other, and basically based on that, we basically work it out manually. We capture that as whether it's a sketch or whether it's a CAD plan or whether it's a SketchUp model, then we basically digitize that into BIM format. I think we're probably not very, very far away. I predict maybe in 5 to 10 years, we will basically start to find people who are designing immediately straight into BIM. Right now, that is not yet happening, at least in our office, and we aspire for that to happen very, very soon. Yeah. Uh-huh. Mm-hmm. Yes. Yes. We grout it. So there's actually, we grout it. So first what we do is, depending on the system that we are using, this is what I was, we basically, depending on the engineer, depending on the contractor, there's a joining system using the rebars, for example, and then we basically grout it. We grout it, and then we basically do the requisite treatment to avoid water seepage and all of these other things. It will not be reflected on plan. So let's say that when you take a look at the brochure plans, they're basically drawn as one column because it's meant to behave as one column and be seen as one column. Yeah. Yeah. You mean you mean structural redundancy? You're gonna have to ask an engineer. My math is not that good. Yes, yes.
Because most of your examples are residential
Yes, yes.
buildings, which are all usually more modular in a way.
Yes, yes.